Okay, this is the video for the first lesson, technically, in Unit 1B. We're going to look at solving two-step equations. Previous lesson, we looked at solving one-step equations. So all the things we learned in that lesson are still valid. We still want to write our equations going down a page. We want to do opposites when we want to move something from one side to the other side. And our aim is just to try and get the variable by itself. So if there are things next to the variable, that's when we want to try and move them to the other side. So we start off with some nice simple questions. All the answers are going to be positive integers, which will keep the math work nice and simple for us, and then we can focus on the procedure. So let's start with question 1 here. 4x minus 3 equals 17. So I'm looking for the x here, and I'm looking what I'm doing to it. Now I can see I've got actually not x this time, but 4x. And then I've got this negative 3 on the end. So I've got number terms on both sides of the equation here, the negative 3 and the 17. So I want to move the negative 3 away from the 4x. So I do that by doing the opposite or the inverse. The reason I do the inverse is if you do negative 3 add 3, you get 0. Anything adds 0 is just the other thing. So 2 adds 0 is 2, 10 adds 0 is 10, 4x adds 0 is just 4x. So that's what we mean by eliminate or cancel out. We just get left with 4x. We must do the same on the other side, though, to keep it balanced. So 17 add 3 is 20. Now we can focus on the 4 and the x together. As they're next to each other, that means multiply. So the opposite of multiplying by 4 is to divide by 4. When we're doing that step, just make sure you don't put the divide symbol. Use the slash symbol like you would for a fraction. And then the same thing, the 4's will cancel by doing the opposite. 4 divided by 4 is 1. 1x, we only ever put x, and that's why it actually cancels. And then 20 divided by 4 is 5. Now, as we're going back through the question, just make sure, if you have time, that you plug this number back into this equation to see if you have the right answer. So 4 times 5 is 20, take away 3 is 17, and it's one of the few units where you can actually check your own answer ahead of time so you'll know if you're correct. Let's take a look at question 2. So this time I've got 8x plus 1 is 33. So I'm not solving for x directly straight away. I'm going to solve for 8x. So I'm going to move the 1 with the 33. So once again, just do the opposite. So instead of adding, I'm going to subtract. Those will cancel on the left-hand side, like this. And then we just work out what the other one is. So 33 take away 1 is 32. Now I don't want 8x though. I just want x by itself. So as they're next to each other, that means multiply. So instead of multiplying by 8, divide by 8. Once again, use that fraction notation. And then the 8's will cancel on the left-hand side. And then on the other side, we can just work out what is 32 divided by 8. And we get 4. For number 3, I put the x in the middle of the equation this time, just to show you what happens when that actually happens. So I still have numbers on both sides here, but I only have variables on this side. So I want to move the number across to this side. So this positive 15 here. So I'm going to do a negative 15. A lot of people want to add 15 here, but if you do that, 15 add 15 is 30. That doesn't cancel. That doesn't make a 0. So we have to do the subtraction for this one. Once we've done that, on the right-hand side, 36 take away 15 is 21. These cancel, and all I have left is positive 3x. So I'm just going to write 3x now to make this a little bit easier for myself. And instead of timesing by 3, you can divide by 3. And then the final step is x equals 7. So just notice while you're doing these questions, a lot of those last steps are often going to be a divide as well. We're often going to end up with some number. In fact, even if it's a fraction, even if it was like 1/2 x, you could still divide by 1/2 to cancel out the 1/2. So something to look out for when we're trying to do questions. That's pretty much always going to be the last step on our questions. Now, in class, we then spent 10 minutes practicing a few questions. Probably not enough time to do all the questions. But certainly enough to you to have a good feel of how to do these. Answers are at the bottom just so you can check you're using the right method. And if you're not using the right method and you were absent from today's class, you might want to stay after school to get a little bit of extra help. Let's move on to our second set of examples. This time all the answers are going to be negative. That doesn't really change anything of how we set up the question, but just to make sure. So I'm going to move the positive 2 to the other side because I'm trying to move it away from the x here. So subtract 2 from both sides. I finish up with negative 18. I know I'm timesing by 3, so do the opposite, which is divide by 3. And negative 18 divided by 3 is negative 6. So that's really the only difference. There's still 2 opposites that I'm doing. But all your answers are going to be negative in this section. So if you don't get a negative answer, once again, it's like a little clue for you that something didn't quite go right. Now, this is our first question actually where the variable appears on the right-hand side of the equal sign. So this time, I don't want to move the 4 across. I actually want to move the 10 to the other side. I want to move it away from the W. So instead of adding 10, I can subtract 10. 4 take away 10 is negative 6, and I get left with this 2W. Divide both sides by 2, and then you can just work out what this is. This will be negative 3. The 2's cancel, leaving you with just W. And for question 3, once again, I've got the x term in the middle because sometimes that can be a little bit more confusing. It's on the left-hand side though, so I'm going to move my numbers away from this. So I'm going to move the 11 to the other side. So it's a positive 11, so I'm going to take away 11. Notice when I write down what I have left after I've cancelled out these 11s, or the negative 11s, I don't go 3x here. I still have to include this negative sign here as well. So I know it looks like a subtract, and subtract and negative are kind of the same thing in mathematics, and I know sometimes that will confuse people a little bit. So make sure you bring the negative sign down with this number here. And then 23 take away 11 is 12. Very possible you might want to do the opposite here and say, well, it says negative 3, the opposite is positive 3. Look at the fact, though, where they're doing to the x. These are actually next to the x, so that means I'm multiplying by negative 3. Therefore, the opposite is to divide by negative 3. The negative 3's cancel, and then 12 divided by negative 3 on the other side is negative 4. If you're not too confident with your negative numbers, nothing wrong with using a calculator just to check that. At this stage, we just want to make sure you understand what you're putting on the calculator, rather than the actual testing of the negative numbers. So use that if necessary. And same thing, you should probably spend around 10 minutes trying to do as many questions as you can. You might not get through 10 questions within that time, but focus on that method rather than just coming up with the answer, okay? And the last one, this could be almost anything, which is kind of like the real life question. It could be positive, could be negative, could be a fraction, could be a negative fraction. So this has a bit of everything in it. I revealed probably a little too much, so let me just quickly cover that part up. So just by looking at the questions, you can't really tell until you start working through them. So instead of adding 2, I'm going to subtract 2 because I'm trying to move it away from the 8x. Negative 18 take away 2 is negative 20. Be careful, I'm still seeing some people put 2 negatives make a positive. Not when you're subtracting necessarily, so just be careful for that. And then instead of timesing by 8, I'm going to divide by 8. And when I say divide here, this is not immediately, hey, negative 20 divided by 8 and come up with a decimal. I want us to simplify that fraction. So notice it divides by 2, so you could put negative 10 over 4. And then you could divide those numbers by 2 as well to come up with this answer. Or you could just divide both by 4. That would be your other option for this. Question 2, I've got my variables on this side, so I'm going to move my numbers across to the left. So instead of adding 4, subtract 4. I get 7. 3w means 3 times w, so divide both sides by 3. And for this one, that's actually it. You can't simplify 7 divided by 3. There is no common factor here, so that's your answer. So with fractions, sometimes they will simplify, and sometimes, like you saw on question 1, and sometimes that is the final answer. Certainly don't put 7 divided by 3 and get an actual decimal. That's not what we're looking for at all with these questions. All right, last one in this section, question 3. 11 minus 12x is 15. So my variable is here, so it's the 11 that I want to move across to the other side. So as it's a positive 11, I'm going to subtract 11 from both sides, because 11 take away 11 is 0. I'm crossing these out sometimes and not other times. You might want to get into the habit of always crossing them out. It's just not easy for me to do on the laptop so easily while I'm showing you. 15 take away 11 is 4. And then last step, divide both sides by negative 12. Negative 12 divided by negative 12 is 1, so that just gives us the x is what we're looking for. And then 4 over negative 12, go ahead and simplify. You can divide by 4, or you could divide by 2 twice. And you would end up with, well, technically you'll end up with 1 over negative 3. You've got to remember to bring the negative to the top of the fraction, though. If you have a positive divided by a negative, the answer is negative, so we always bring the negative to the top of the fraction when you're doing those questions. And same thing, 10 more minutes practice on these questions here. The answers are at the bottom. There's a few less questions this time. You might be able to get a little further into these ones, just to make sure you understand. Now, having tried the basic problems, what we really need to do is look at some application problems. So I picked this one from geometry, because that's going to be useful for next year as well, but with much nicer numbers to begin with. So we're given a fact here that the sum of angle measures is 180 degrees, We know sum from our first unit means we're going to add these together. So I'm going to add 2m plus 2m plus m together. And when I do that, the answer is going to be 180. Now, a little bit of collecting terms here. Let me just scroll up a little bit here. So 2m plus 2m. If you see m, remember what it means is it just means 1m. I know some people like to write the 1 there just to remind themselves. So when I add those together, I get 5m. 2 plus 2 plus 1. I'm not saying m cubed here, which I know sometimes people like to do. If you had like 2 mice plus 2 mice plus 1 mouse, you'd have 5 mice. You wouldn't have like 5 mice cubed. So same sort of idea. You're just saying how many m's do I actually have. Equals 180 because it tells us that in the question. And then as the m and the 5 are next to each other, you can just go ahead and divide both by 5 and you get 36. If you wanted to know each individual angle, just substitute back. 2 times 36 is 72. And this would also actually be 2 times 36, which is 72 as well. Now, for the one on the other side, I think there's a slightly different shape here. There we go. We've got a quadrilateral, four-sided shape. And the fact for four-sided shapes is that they add up to 360. So when I add all these together, it must be 360. Now, not all these are like terms. Some have variables and some have numbers. So just collect the like terms together. So 2x plus x is 3x. And 120 plus 90 is 210. Now you might just want to write out all the angles first and show that it's 360 and then simplify, and you can absolutely do that. That would be perfectly okay. 2x plus x, 120 plus 90. And then now I can start solving like I've been doing in all this lesson. Move things away from the x. So bring your numbers together first. So subtract 210, which would give you 150. And then you can divide by 3, which would give you your answer as 50. So this answer here, as it's just x, would be 50. And this angle here where it says 2x would be 2 times 50, which is 100. And to link back to our first unit that we did, a few word problems. We only had verbal expressions in our first unit, so verbal equations is also something we can do as well. So when we see difference, we know that means subtract. What are we subtracting? A number doubled, so that means you're timesing it by 2, and then 12. The is part just tells you that that's what it's equal to. So that's another key word for when we're doing these types of question. From here, just use your method we've been using all lesson. Add 12 to both sides. Divide by 2. I'm not showing the opposites for this. I'm just going to go ahead and talk what they are. That's the part that we should be okay with now. So once we know how to solve these, we can also make sure you know how to set up the problem as well, which is kind of why we did the Unit 1A first. The sum of a number tripled, and 4 is a negative 11. So sum I know means add, so I'm going to put that in the middle. A number tripled means I times by 3, so 3n. And then the is 11, negative 11 again means equals to negative 11. Numbers to this side, take away 4 from both sides, divide by 3, and there we have our answer. So a few different things to practice while we're doing those questions. That's certainly it for this video. Go practice. There will be an assignment that goes with this exercise. Take a look at that. If necessary, look at the links below. There are more videos on the YouTube page as well. And you can certainly contact me with any other questions. But for right now, that's it for this video.